Now, the potential difference is W over Q and I is Q over T. If I multiply them together, I will get the work done per unit charge, yet current is the charge per unit time. And so W over Q times Q over T simply gives me the work done per unit time, which is power. And so the electrical power is simply I times V. If we combine this with the fact that V equals to IR, then you can see that there are alternative ways of finding the electrical power. So we can have I equals to I times IR, and this would be I squared R. Or maybe if we say we let I equals to V over R, then P could then equal to V over R times V, which equals to V squared over R. And so we have three ways of thinking of the electrical power, all of which are the same thing. And so when we look at something like this, a lot of times in the A levels, when we talk about electrical power, they are typically used to measure the brightness of a certain light bulb. And so, of course, power not just affects the brightness of a light bulb, but more generally, it affects the performance of any component. So just ensure, right, that when we use these formulas, IV, I squared R, V squared over R, we have to ensure that I, V, and R are correct. And so we have to be specific to the power of the component that we're trying to find. Make sure that I is always the current through the component, R is the resistance of the component, and V, of course, is the potential difference across the component.